The world wireless system was a turn of the 20th century proposed telecommunications and electrical power delivery system designed by inventor Nikola Tesla based on his theories of using Earth and its atmosphere as electrical conductors. He claimed this system would allow for the transmission of electric energy without wires, on a global scale, as well as point-to-point wireless telecommunications and broadcasting. He made public statements citing two related methods to accomplish this from the mid-1890s on. By the end of 1900 he had convinced banker J.P. Morgan to finance construction of a wireless station, eventually sited at Wardenclyffe, based on his ideas intended to transmit messages across the Atlantic to England and to ships at sea. Almost as soon as the contract was signed, Tesla decided to scale up the facility to include his ideas of terrestrial wireless power transmission to better compete with Guglielmo Marconi's radio-based telegraph system. Morgan refused to fund the changes and, when no additional investment capital became available, the project at Wardenclyffe was abandoned in 1906, never to become operational. During this period, Tesla filed numerous patents associated with the basic functions of his system, including transformer design, transmission methods, tuning circuits, and methods of signaling. He also described a plan to have some 30 Wardenclyffe-style telecommunications stations positioned around the world to be tied into existing telephone and telegraph systems. He would continue to elaborate to the press and in his writings for the next few decades on the system's capabilities and how it was superior to radio-based systems. Despite claims of having carried on practical experiments in wireless transmission, there is no documentation he ever transmitted power beyond relatively short distances, and modern scientific opinion is generally that his wireless power scheme would not have worked. History. Origins. Tesla's ideas for a world wireless system grew out of experiments beginning in the early 1890s. After learning of Hertz's experiments with electromagnetic waves, using induction coil transformers and spark gaps, he duplicated those experiments and then went on to improve Hertz's wireless transmitter, developing various alternator apparatus and his own high-tension transformer, known as the Tesla coil. His primary interest in wireless phenomenon was as a power distribution system, early on pursuing wireless lighting. From 1891 on, Tesla was delivering lectures including experiments with alternate currents of high potential and high frequency, in 1892 in London and in Paris, and went on to demonstrate wireless lighting in 1893, including lighting Geissler tubes wirelessly. One-wire transmission equals. The first experiment was the operation of light and motive devices connected by a single wire to one terminal of a high-frequency induction coil, performed during the 1891 New York City lecture at Columbia College, while a single-terminal incandescent lamp connected to one of an induction coil's secondary terminals does not form a closed circuit. In the ordinary acceptance of the term, the circuit is closed in the sense that a return path is established back to the secondary by capacitive coupling, or displacement current. This is due to the lamp's filament refractory button capacitance relative to the coil's free terminal and environment. The free terminal also has capacitance relative to the lamp and environment. Wireless transmission equals. The second result demonstrated how energy can be made to go through space without any connecting wires. The wireless energy transmission effect involves the creation of an electric field between two metal plates, each being connected to one terminal of an induction coil's secondary winding. A gas-discharged tube was used as a means of detecting the presence of the transmitted energy. Some demonstrations involved lighting of two partially evacuated tubes in an alternating electrostatic field while held in the hand of the experimenter. development. While formulating his theories in the early 1890s, Tesla discarded the idea of using radio waves. Not only did he not believe they existed as theorized, he agreed with what most physicists were saying at the time, that they would travel in a straight line propagation similar to light, making them useful for only short-range communication. This was many years before the discovery that there was an ionosphere that would reflect radio waves, making long-range communication possible. He theorized that transmitting electrical signals any distance would require the use of planet Earth as conducting media to overcome this limitation. By the end of 1895, he was making statements to the press on the possibility that Earth's electrical charge can be disturbed, and thereby electrical waves can be efficiently transmitted to any distance without the use of cables or wires to transmit intelligible signals, and motive power. In April 11, 1896, he made another statement that he believed messages might be conducted to all parts of the globe simultaneously, using electric waves propagated through the atmosphere and even the ether beyond. In September 1897, he applied for a patent on a wireless power transmission scheme consisting of transmitting power between two tethered balloons maintained at 30,000 feet, an altitude where he thought a conductive layer should exist. Between 1895 to 1898, he constructed a large resonance transformer in his New York City lab called a magnifying transmitter to test his Earth conduction theories. In 1899, he carried out large-scale experiments at Colorado Springs, Colorado. From his measurements there, he concluded the Earth was literally alive with electrical vibrations. Quote, he noted that lightning strikes seemed to show the Earth was indeed a big conductor, with the waves of energy from each strike going from one side of the Earth to the other. He constructed a large magnifying transmitter measuring 51 feet, 15.5 meters, in diameter, which could develop a working potential estimated at 3.5 million to 4 million volts, and was capable of producing electrical discharges exceeding 100 feet, 30 meters, in length. With it he tested Earth conduction and lit incandescent electric lamps adjacent to his lab in demonstrations of wireless power transmission. Upon returning to New York City from Colorado Springs in 1900, he sought venture capitalists to fund what he viewed as a revolutionary wireless communication and electric power delivery system using the Earth as the conductor. By the end of 1900, he had gained the attention of financier J.P. Morgan, who agreed to fund a pilot project, later to become the Wardenclyffe project, which, based on his theories, would be capable of transmitting messages, telephony, and even facsimile images from across the Atlantic to England and to ships at sea. Morgan was to receive a controlling share in the company as well as half of all the patent income. His decision in July 1901 to include wireless power transmission to better compete with Guglielmo Marconi's new radio-based telegraph system was met with Morgan's refusal to fund the changes. Construction of the Wardenclyffe wireless plant in Shoreham started towards the end of 1901 and continued for the next 3 years. The plant included a Stanford White-designed 94 by 94 feet, 29 by 29 meters, brick building, a wood-framed tower 186 feet, 57 meters, tall with a 68 feet, 21 meters, in diameter, cupola, on top, and a 120 feet, 37 meters, shaft sunk into the ground with 16 iron pipes driven, one length after another, 300 feet, 94.4 meters, below the shaft in order for the machine, in Tesla's words, to have a grip on the Earth so the whole of this globe can quiver. Funding problems continued to plague Wardenclyffe, and by 1905, 1906, most of the site's activity had to be shut down. Elements. Through the latter part of the 1890s and during the construction of Wardenclyffe, Tesla applied for patents covering the many elements that would make up his wireless system. The system he came up with was based on electrical conduction, with an electrical charge being conducted through the ground and as well as through a theorized conducting layer in the atmosphere. The design consisted of a grounded Tesla coil as a resonance transformer transmitter that he thought would be able to create a displacement of Earth's electric charge by alternately charging and discharging the oscillator's elevated terminal. This would work in conjunction with a second Tesla coil used in receive mode at a distant location, also with a grounded helical resonator and an elevated terminal. He believed that the placement of a grounded resonance transformer at another point on the Earth's surface in the role of a receiver tuned to the same frequency as the transmitter would allow electric current flowing through the Earth between the two. He also believed waves of electric current from the sending tower could be made to reflect back from the far side of the globe, resulting in amplified stationary waves of electric current that could be utilized at any point on the globe, localizing power delivery directly to the receiving station. Another aspect of his system was electricity returned via an equivalent electric displacement in the atmosphere via a charged conductive upper layer that he thought existed. A theory dating back to an 1872 idea for a proposed wireless transmission-reception system, developed by Marlon Loomis. The current could be used at the receiver for telecommunications and to drive electrical devices. Tesla told a friend his plans included the building of more than 30 transmission-reception stations constructed near major population centers around the world, with Wardenclyffe being the first. If plans had moved forward without interruption, the Long Island prototype would have been followed by a second plant built in the British Isles, perhaps on the west coast of Scotland near Glasgow. Each of these facilities was to include a large magnifying transmitter of a design loosely based upon the apparatus assembled at the Colorado Springs Experimental Station in 1899. Claimed applications. Tesla's description of his wireless transmission ideas in 1895 include its humanitarian uses in bringing abundant electrical energy to remote underdeveloped parts of the world and fostering closer communications amongst nations. His June 1900 Century magazine article, The Problem of Increasing Human Energy, includes photographs of his Colorado Springs experiments and his thoughts on how Hertz's experiments were not an experimental verification of the poetical conceptions of Maxwell. Quote, he elaborated on his system of using Earth as the medium for communication and power delivery. He wrote how he could set up communications at any distance. He noted his system could localize electrical delivery to a point on the globe via stationary waves. He also noted this same process could be used to locate maritime objects such as icebergs or ships at sea. In 1909, Tesla stated, "It will soon be possible, for instance, for a businessman in New York to dictate instructions and have them appear instantly and type in London or elsewhere. He will be able to call up from his desk and talk with any telephone subscriber in the world. It will only be necessary to carry an inexpensive instrument not bigger than a watch, which will enable its bearer to hear anywhere on sea or land for distances of thousands of miles. One may listen or transmit speech or song to the uttermost parts of the world." Quote, he also believed that high-potential electric current flowing through the upper atmosphere could make it glow, providing nighttime lighting for transoceanic shipping lanes. He elaborated on world wireless in his 1919 Electrical Experimenter article titled The True Wireless detailing its ability for long-range telecommunications and putting forward his view that the prevailing theory of radio wave propagation was inaccurate. The Hertz wave theory of wireless transmission may be kept up for a while, but I do not hesitate to say that in a short time it will be recognized as one of the most remarkable and inexplicable aberrations of the scientific mind which has ever been recorded in history. Quote, feasibility. Tesla's demonstrations of wireless power transmission at Colorado Springs consisted of lighting incandescent electric lamps positioned nearby the structure housing his large experimental magnifying transmitter, with ranges out to 1,938 feet, 591 meters, from the transmitter. There is little direct evidence of his having transmitted power beyond these photographically documented demonstrations. He would claim afterwards that he had carried on practical experiments in wireless transmission. Quote, he believed that he had achieved earth electrical resonance that, according to his theory, would produce electrical effects at any terrestrial distance. There have been varied claims over the years regarding Tesla's accomplishments with his wireless system. His own notes from Colorado Springs are unclear as to whether he was ever successful at long-range transmission. Tesla made a claim in a 1916 statement to attorney Drury W. Cooper that in 1899 he collected quantitative transmission reception data at a distance of about 10 miles, 16 kilometers. Tesla biographer John J. O'Neill made a claim in his 1944 book Prodigal Genius, The Life of Nikola Tesla, that in 1899 at Colorado Springs Tesla lit 200 incandescent lamps at a distance of 26 miles, 42 kilometers. The writer Mark Cypher in his book Wizard, The Life and Times of Nikola Tesla noted opinion amongst Tesla proponents that ranged from the idea not being practicable to claims that some of Tesla's observations were valid. Other investigators have stated that Tesla overestimated the conductivity of the Earth and the atmosphere, and vastly underestimated the loss of power over distance. Related patents. System of electric lighting. April 25, 1891. U.S. Patent 454622. June 23, 1891. Means for generating electric currents. August 2, 1893. U.S. Patent 514168. February 6, 1894. Electrical transformer. March 20, 1897. U.S. Patent 593138. November 2, 1897. Method and apparatus for controlling mechanism of moving vessel or vehicles. July 1, 1898. U.S. Patent 613809. November 8, 1898. System of transmission of electrical energy. September 2, 1897. U.S. Patent 645576. March 20, 1900. Apparatus for transmission of electrical energy. September 2, 1897. U.S. Patent 649621. May 15, 1900. Method of intensifying and utilizing effects transmitted through natural media. June 24, 1899. U.S. Patent 685953. November 5, 1901. Method of utilizing effects transmitted through natural media. August 1, 1899. U.S. Patent 685954. November 5, 1901. Apparatus for utilizing effects transmitted from a distance to a receiving device through natural Media. June 24, 1899. U.S. Patent 685955. November 5, 1901. Apparatus for utilizing effects transmitted through natural media. March 21, 1900. U.S. Patent 685956. November 5, 1901. Method of signaling. July 16, 1900. U.S. Patent 723188. March 17, 1903. System of signaling. July 16, 1900. U.S. Patent 725605. April 14, 1903. Art of transmitting electrical energy through the natural mediums. May 16, 1900. U.S. Patent 787412. April 18, 1905. Art of transmitting electrical energy through the natural mediums. April 17, 1906. Canadian Patent 142352. August 13, 1912. Apparatus for transmitting electrical energy. January 18, 1902. U.S. Patent 1,119,732. December 1, 1914. See also: wireless energy transmission, surface plasmon, surface wave sustained mode, transmission medium, distributed generation, electricity distribution, electric power transmission, apparatus, electric generator, isochronous electromechanical oscillator, Tesla coil, magnifying transmitter. Notes. Further reading. Boundless space. A bus bar. The Electrical World. Volume 32. No. 19. November 5, 1898. Tesla. Nikola. The Problem of Increasing Human Energy with Special Reference to the Harnessing of the Sun's Energy. Century Magazine. June 1900. Tesla. Nikola. The Transmission of Electrical Energy Without Wires. Electrical World and Engineer. January 7, 1905. Massey. Walter Wentworth. Wireless Telegraphy and Telephony Popularly Explained. New York. Van Nostrand. 1908. With special article by Nikola Tesla. Tesla. Nikola. The True Wireless Electrical Experimenter. 1919. Tesla. Nikola. World System of Wireless Transmission of Energy. Telegraph and Telegraph Age. October 16, 1927. Electric Spacecraft, a Journal of Interactive Research by Leland Anderson. Rare Notes from Tesla on Wardenclyffe in issue 26. September 14, 1998. Contains drawings and selected typescripts of Tesla's notes from 1901. Archived at the Nikola Tesla Museum in Belgrade. PBS Tesla Master of Lightning Tower of Dreams. Global Wireless Telecommunications. Wardenclyffe Tower at Structure.